This video is gonna be a comparison between how dilution equation can be utilized in two different ways, okay? But one of the things that you have to understand is to interpret interpreting what the question is telling you in order for you to be able to utilize the equation correctly. Because part of this is not just because you plug in number, it doesn't make sense because certain information will give you certain guidance and that will lead you certain informations, and at the end of the day you're gonna have to see whether or not your answer makes sense, whether or not your concentration should be more or less based on the amount of solvent left in the solution after the change. Okay, let's get back to the first one on the left. We're still talking about the concentration of sodium hydroxide dissolved in water, because we know for sure that the sodium hydroxide will dissolve in water, and that's why we do it. So first we have this 0.5 molarity, and then first we have 250 ml of water. That's what we have, that's the volume. And after dilutions, what happened is that we added 500 more water. We're trying to figure out what the final concentration is. So we're gonna have to utilize the equation, which is exactly the same, by first molarity of the first one, which is 0.5. The volume of the first one, I'm just gonna do it in liter just to be more consistent. Second concentration, I don't know. But then this is the final volume, which is final after adding water, okay? So you're gonna have to see what makes sense. So first you have 250, and then you added more, and that would be 750, which is this. So then you're gonna have to figure out what your second concentration is by simply multiplying those two numbers, 0.5 concentration times 0.25 liter divided by 0.75, because it's the total concentrations of the water, of the solvent, 0.167 molarity. Let's put it this way. First you have 0.5, and after dilution you have how many? 0.167, which is less than what you have, since you have more of the solvent, which is correct. Because since both sides of the equation, they must be equal, that's why they have an equal sign for reasons. Then we're gonna do another equation over here. So first we have simply the same thing, sodium hydroxide dissolved in 500 ml for the very first time. The concentration still be the same. This is just an example of the questions, okay? This is concentration, that's the volume. But after certain things happen by heating, what happens when you add more heat to the solvent, which is water? So first of all, many of water molecules will be evaporating. At certain time, then they will have certain volumes left, which is this much. Okay, we're trying to figure out what the final concentration is after the water has been evaporated. So M1, which is the initial concentration, which is 0.5. That's 0.5 because 500 ml is equal to 0.5 liter. Second concentration we don't know. Then we're looking for the volume, which is 0.15. So for this one, since they have less volume than before, then the concentration should be more. We just want to confirm if that's true. If that's true. 0.5 times 0.5, 0.5 times 0.5 divided by 0.15. And the answer is 1.67 molarity. So basically the second concentration over here is more than that, which is confirmed based on our theory. So basically the second concentration over here is more than that, which is confirmed based on our theory. So basically the second concentration over here is more than that, which is confirmed based on our theory. So basically the second concentration over here is more than that, which is confirmed based on our theory. So basically the second concentration over here is more than that, which is confirmed based on our theory. So basically the second concentration over here is more than that, which is confirmed based on our theory. So basically the second concentration over here is more than that, which is confirmed based on our theory. So basically the second concentration over here is more than that, which is confirmed based on our theory. So basically the second concentration over here is more than that, which is confirmed based on our theory. So basically the second concentration over here is more than that, which is confirmed based on our theory. So basically the second concentration over here is more than that, which is confirmed based on our theory. So basically the second concentration over here is more than that, which is confirmed based on our theory. So basically less solvent, more concentration of the solute, because there are more number of moles. More solvent, less concentration of solute, the concentration should be less. That's what it is.